Again, good morning, guys, and welcome to our CPD webinar, Unfit to EnerPHit, Transforming Tradition into Performance, with Dr. Barry McCarron here, Managing Director at KORE Retrofit. So if you guys have any questions, you can pop them in the chat function just above or in the Q&A, and we will get to them at the end of the webinar. So this webinar will look at the fundamentals of EnerPHit and how EnerPHit differs from the regular standard of retrofit. We will look at the challenges as well as the design, materials and workmanship strategies. And finally, we will look at a live project we have right now that will be undertaken in Dublin. So without further ado, I will hand you over to Dr. Barry McCarron.
Brilliant. Thank you, Lisa. Just to check, Lisa, can everybody hear me all right? Can you hear me?
I can hear you, yeah.
Brilliant. Okay. Yeah, welcome along, everyone. As Lisa said, she's given a good outline there, so I'll just jump in and kick off and we'll go from there. I always like to be sort of to the point with the presentations, and hopefully that feeds a good bit of Q&A on the other side, where I think the real richness can be gathered in these things. So a little bit for anybody that doesn't know about us, I'm currently in KORE, I think up on 16 months now. I suppose we should start with KORE Group. We have two sides of the business. I'm of course on the retrofit side, and that's where we're talking at today, but it would be remiss of me if I didn't mention the other side of the business, which of course is an insulation manufacturing business, and that is what we're probably have been better known for historically, and KORE Retrofit's the younger of the two arms of KORE. And again, within this space, we are really on the retrofit side, going now 2017 in terms of KORE Retrofit. It's family run, based in Cavan. Then since we've come into the retrofit space, we've really been focused on quality retrofit solutions and really always trying to take a leadership role within the sector, pushing into new areas all the time. And as we move from NZEB in terms of building regulations towards ZEB, which is zero energy buildings, alongside that, we feel that the passive house methodology, in particular the classification for retrofit under passive house called EnerPHit, is really the thin end of the wedge in terms of leadership into that space. So that's a little bit of our story. In terms of the services that we offer in KORE Retrofit, we are, of course, the very first one-stop shop, and we've been joined now by, I think altogether, we're up in 24, 25 one-stop shops within the sector, under the SCI umbrella, delivering retrofit to all these homes. And internally, then we can also, conduct the vacant derelict property grant for people, and we've worked with most of the counties now around the country. So that's a key service for us now, and a big, I suppose, driver of some of the projects that we have at the moment. Also, but maybe lesser known, is that you can also engage with a one-stop shop as part of the defective block concrete scheme. So if you have your redress funding, an additionality on top is that you can also avail of some of the energy upgrades under the defective block scheme. Then as well, in terms of the services, we have a traditional homes pilot, which is underway now from earlier on this year, and that's for homes that are pre-1940s, and within that space, they would have maybe a different treatment to standard retrofit. So within that scheme, we're very much leading there as well. And again, the fully funded situation, just to go back to the pillar programs, I suppose we've the grant scheme. In terms of two pillars, we have the warmer home scheme, which we're very strong in, and then also on the other side, the one-stop shop, which I've give a good overview of the different aspects to that as well. But we also work in Northern Ireland as well with the NICEP program in Northern Ireland, and a strategic pillar for us going forward will be the commercial retrofit space as well, where we're trying to lean into that more and more, particularly hopefully with education and healthcare going forward, to build on our existing portfolio in that space. So as Lisa outlined at the start, today is really, the title of it is Unfit to EnerPHit, which is a nice play on words, but really it's about taking in the retrofit, homes that are due that upgrade or that coming to the end of one phase of a generation and moving into another. So we're going to really, I suppose, walk you through a little bit of that. The key aspect of any retrofit for me will always be across 5 really key elements, and those will be your floors, your walls, your roof, and you will be depending on the upgrade, depending on the classification, depending on the scheme, you'll be going to as good a level as you can with those. So your floors, walls, and roof, you're improving typically the U values, and again, agnostic to materials. I suppose with the exception of the traditional homes pilot, whereby the careful consideration is needed there as well. Then what this then will bring into play then will be, special care and attention about thermal bridging. Thermal bridging is the junctions of your floor to your walls to your roof, and also the area where your windows are set into the walls. Those are typically your thermal bridging, and I've got a nice illustration coming up on that for everyone. But those thermal bridges in a retrofit are harder to iron out than they are in a new build construction. In a new build construction, you're at the design stage and you have a blank page. With retrofit, that's not the case. So you're trying to really mitigate thermal bridging, and it's an important consideration within retrofit. Third principle then that we would look at is typically high performance glazing, and also optimizing your glazing depending on the elevation as well. And typically in this space, you are probably looking to have appropriate glazing to the south, but also, and this isn't talked about so much, is probably trying to minimize your glazing to the north in order to avoid things like overheating with too much to the front, and we'll talk a little bit more about that in a moment, but also on the northern side so that you're not hemorrhaging unnecessary heat there as well. So that's the third principle. And then the fourth and fifth really go hand in hand. You're going to make a building deliberately airtight. You're going to get that airtightness level, and if it is EnerPHit, of course, you're going to go to a set number, which is 1 air change per hour. And with that, there's no fear, because you're going to mechanically ventilate your building. And again, within EnerPHit, for example, in terms of this leading standard, you're going to go with mechanical heat recovery ventilation. And those 5 things come together to really push down the heat and demand of a building. And if your heat and demand of a building is pushed down to a really good level, which again, speaking on EnerPHit, is 25 kilowatt hours per meter squared of floor area in your home, that means that if you do bring into play a renewable energy solution, that renewable energy solution is much, much, much more accurate, and is much more likely to really deliver for the home and for, of course, the homeowner. So that's really a picture of EnerPHit. Again, I haven't gone too deep, trying to keep it palatable, just to again illuminate Q&A later on, but we'll walk you through this example of a house that we have in Glasnevin in Dublin in due course here, and that'll help dig into a little bit more technical. But first of all, I'm going to give you an overview of some of the EnerPHit projects that we have. The first one is almost breathtaking in some respects. We're very lucky to have David as a client, and this is a little cottage up in Donegal that's in a very scenic position overlooking the sea, and with that it'll have its challenges. Look out for future webinars due to go to site there later this month, and I think we'll replicate a lot of this presentation or style of CPD, but through the lens of that project. And then just to show the variety that you get in retrofit, and not being too tongue-in-cheek there, we have this one in Howth, for example, and again, very typical of the bungalow bliss type era. You're talking 60s, 70s there, brick construction. Again, looking at the foliage that's grown on it and all, it's a very quaint place. But again, that's destined for an EnerPHit project as well. And Then we have, of course, the project we're going to talk about today, which again is on the north side of Dublin in Glasnevin. And again, we're looking at a period home here. You can see there the different facade to it, where there's a little bit of brick and again a rendered finish up on top, and then the rest of the building is rendered to the front and back in its original state, and now it has a significant extension to the rear with new build construction. So we're going to have a look at that. So here we go. The original building, when we got the pre-BER done, came in at 405 kilowatt hours per meter squared, and the post BER was aiming for an A1, which would come in at 21 kilowatt hours per meter squared per year. So again, this floor has 201 meters squared. That's the scale of the house. And again, let me just indulge you then in talking about the form factor. So the form factor for this building is 2.6, which is not bad. You would say that's middle of the road. So if you can maybe see my mouse on screen, I'll show you down here in the design PH model. If we were, or we had the luxury to, let's say, pull forward this elevation to here, you would probably find that the form factor would decrease, go to a lower number. So the lower the form factor, the more easy it is to make a building energy efficient. So if you were to take a skyscrapers and big buildings with good surface to volume ratios, they'll always be in and around 1 or even below that. And probably the very worst type of building to tackle is something like an L-shaped bungalow, which we'd be familiar with in Ireland, and it could be up at 3, 4, and with that, you typically have to compensate for the poor form factor with extra, specification, typically increased levels of insulation to the floors, walls, and roof to make up for that. So that's just bringing that into play. In terms of explaining it, the heat and demand for the building will be, as modelled, as you can see here with design PH and PHPP at 21 kilowatt hours, and the heat and load, which some in the room might be very interested to know, is at 13 watts. So on the worst day of the year, to keep this building at 21 degrees, it'll take 13 watts per meter squared. And then the floor, walls, and roof typically are all below 0.15, which of course corresponds with the building regulations as well here in Ireland. So I did say I had a nice image for thermal bridging to try and get that across for everyone. So when modelling in Passive House, you're able, as you've seen in the previous slide, to do this in Design PH, which is through SketchUp. But one of the things that's very neat about that is you can copy and paste then your model, and you can delete all the facades. And then what you're left with is the stick frame of the building, essentially. And again, when now we're looking at this stick frame, and you go back to an earlier comment I made, it's the junction of the floors to the walls to the roof, and then the windows in the fabric as well. So you can clearly see that in the stick frame. But what's very interesting, and we always try to have a reference point, hence the Empire State Building, but if you were to add up all the linear thermal bridges in this house in Glasnevin, it comes to 405 meters of thermal bridging. And of course, the Empire State Building's 381. So what I'm trying to do there is illustrate the importance of thermal bridging and what impact it can have. And again, in my journey in the construction industry, this is something that maybe has been underappreciated and has a significant impact on our buildings and indeed the performance of our buildings. So I just wanted to draw that out in terms of a discussion point. One of the other things that the Passive House standard brings into play, and of course for a retrofit with EnerPHit, is that there is an assessment of overheating. So if we are looking at this building here, as you can see in the image, we're looking at the rear of the house here. And when we look at it there, we can see that it's basically in a desert. I haven't drawn any of the corresponding streetscape, which is there in Glasnevin. I haven't drawn in the trees. I haven't drawn in trees to the rear. So when conducting the initial modelling, this is the way to go, because then you can really stress test the building. So all buildings that meet passive house can't overheat more than 10% of the year. So this building, in the worst case scenario, in the middle of the Sahara Desert type scenario, comes in at 9% of the year. But of course, when we draw in the streetscape and we use the strategies that are within passive house, and again, some people might have questions on that, I can speak to that, it comes in at 1%, which means that this building, albeit it's built to EnerPHit, passive house, and it will comply with future regulations in terms of ZEB, and being A1, is at no risk of overheat. So that's another thing that I really wanted to get across as a learning outcome from this CPD. Then moving on, I suppose one of the best ways to communicate, in my experience, all of these things is to talk about pounds and pence. So what is the building expected to do when it's finished? If you look at what I've got on the slide here, you'll see that the expected heating cost with an air-to-water heat pump for the entire year will augment out at €488 based on the PHBP. I've been fortunate enough to retrofit my own house, which is a bungalow, and those of you who've been paying attention will know that it's a poor form factor and all the rest of it. But this corresponds quite closely to the performance of my own home and the numbers of my own home. And what I have found is that I'm not experiencing a performance gap, which is a key part of this story as well. So that's for this home at Glasnevin, that's what the heating cost has come in. Interestingly, and very commonly in a passive house, the domestic hot water will be more than the heating demand. That's a key indicator I would always look for in a project like this. And you can see there it's approximately €100 more in terms of expected running cost to heat the hot water for this home. And then the electricity demand and the expected cost is very predictable. Again, electricity in some respects, without bringing into play a conversation on solar PV, which I will in a minute, is going to come in based on occupancy. The loads in a house are quite predictable. So 1,500 is roughly where this home will come in. So, and then to just show the power of solar, again, which is commonly part of our retrofit solutions, a 4 kilowatt system here, which is optimized roof orientation, would probably yield about 3,200 kilowatts. Typically, you only get to use about 50% of that. So that 1,500 would come down to 936 in terms of a prediction of running costs. So that just sort of shows you there. So all in all, you're talking 2,000 to 2,500 for all energy for this passive house EnerPHit. Now, and there you go. That's what we're saying. So that's all right. So if you go back to the very start of when we started to introduce the BER rating for this building, it was an F rated building. So if this building was to stay as an F and it was to run, the total energy would be 6,000, or sorry, the savings based on the F are in the region of 6,100. But it's not really practical to do that because the house wouldn't have been left in that state, and it's not a fair comparison. It's not doing anybody justice that's joined us today in the webinar to pitch up an unrealistic situation and to probably have figures that look really good. So 6,100, I would typically score through that and not bring that to the page, because the running cost, if it had stayed at an F, was up around 8,000. But what I have brought into play then is a B2. So very often the minimum level for retrofit is a B2, and within KORE Retrofit now, with the building regulations about to change, we're really putting the minimum bar now at an A3, which is sort of outlined to us. So B2 is a realistic comparison. So if we're looking at the overall energy costs for this building, if it was a B2 versus passive house EnerPHit, the saving to go from a B2 to an EnerPHit is actually just short, as you can see there, of €2,000 a year. And again, if you're taking a typical mortgage period, and again, really looking at some of the learning that comes from experience in, say, the Passive House Designers course or Consultants course, they do encourage you in Germany to really look at the mortgage period, because that is very often the decision, and it's the savings over that time period that are really relevant. So if you take 2,000, or just less than 2,000, 1,900, and you augment that over 30 years, and we're not bringing into play increases in fossil fuel, inflation, interest rates, anything like that, leaving this all conservatively, you're just talking under 60,000 euros in terms of saving over that period of time for a project like this, to go that extra few yards to something like Passive House EnerPHit. So very often I get asked a question around how much more is it going to cost to go to EnerPHit. The good news story is, with our building regulations, and again, the next wave of the building regulations coming on board in May next year, this gap is getting smaller and smaller and smaller all the while. So there's really no reason not to pursue EnerPHit, but by certification, or the next best thing, which is an EnerPHit modeled in PHBP and Design PH, where you get that accuracy. So yeah, that's a walkthrough of a lot of the figures on that. And again, by deliberately, I suppose, going there with figures and discussing things like that, it should pull out a good bit of Q&A, I hope. We were fortunate to have a site visit there with the Irish Green Building Council not too long ago, and it was a very successful event, and you can see some of the pictures here that Lisa's pulled together from that. The project is due to finish in January 2026 now, so we're very close. We're coming to the end of the project, and look out for next year sometime. I think the client is very engaged in all of this, and with their home, it could appear in the Passive House Open Days next spring, next summer, and next autumn. So the project, and when it comes to full completion, should probably have an active role in those particular open days that occur a couple of times a year within the Passive House community. And again, we as KORE, as I suppose one of the actors in the project, will see. So watch this space is probably the long and short of it. So Lisa, that's me in terms of running through the presentation. You can see our contact information there, socials as well. Don't be afraid to reach out. But let's open the door to a bit of Q&A.
Thanks, Barry, and thanks for a great presentation. And as you said, we did visit the house in September, and it's incredible to see the difference so far. So we did have some questions in before the webinar that anybody that registered had some. So I'll just start off. So firstly, is it possible for heritage buildings such as stone buildings to have an EnerPHit upgrade?
It is indeed, yes. So again, EnerPHit has metrics in it like 25 kilowatt hours per meter squared per year. And if you look at a heritage building and you look at a figure like that, it's very, very hard maybe for a heritage building to reach that. But of course, common sense is in play. And to a certain degree, the EnerPHit standard does mirror a lot of where the SCDI is going in terms of good quality retrofit. So what you want to do with a heritage building is never to sacrifice the health of the building, be it in interstitial condensation, surface condensation, or indeed bad indoor air quality. You want a building that performs ultimately. So EnerPHit has a pathway for that, and what it's called EnerPHit by component. And if you're using high quality components, you can attain the EnerPHit standard. But the numbers in terms of 25 kilowatts per hour, you can be way north of that. You could be 85, whatever the number may be. So long as you have, with each of the 5 principles, used the appropriate components in the process, you can demonstrate and you can attain the EnerPHit standard. So good question. Yeah.
Thanks, Barry. And then next in our chat, we have a question from Emma. So do you work with engineers or architects on design measurements for clients who are undertaking an extension and a retrofit? And is it possible for a dormer to have an EnerPHit retrofit?
Yeah, so the first one is, yeah, again, in terms of professional engagement, very often we typically have two real main buckets of retrofit within the one-stop shop environment. What you will typically get is a home that is getting no increase in terms of modifications, no extension, no internal movements and walls. You could just call it an energy upgrade. And sometimes that can still be quite deep in terms of the measures that are going to be undertaken. You will typically get is a home that is getting no increase in terms of modifications, no extension, no internal movements and walls. You could just call it an energy upgrade. And sometimes that can still be quite deep in terms of the measures that are going to be undertaken. So within that, that's something that the one-stop shop can typically handle. Where you have extensions and that there will always be professional engagement there as well. And the dovetailing of the one-stop shop and the professionals in that regard, we're many hundreds of projects, even thousands done now, maybe at this stage, from we were set up as a one-stop shop, and there's no barrier to doing business in that regard. Moving on then to the next part of that question, which was around the dormer. Absolutely not a problem in terms of getting to EnerPHit. The one thing I would say is that the dormer typology is probably one of the most challenging, potentially, in particular with airtightness. But there would be examples of it being achieved before to the full EnerPHit standard, but you're probably putting it into the silo of a deep retrofit, whereby you need to strip a lot back to get to the, I suppose, the nuts and bolts of achieving, in particular, probably airtightness being the biggest challenge within that.
Thanks, Barry. And we've a question here from Eva. You mentioned building regulations are changing in May next year. Can you expand on that, please?
Yeah, so again, like everybody else, I'm waiting for it. It's downstream from the EU directive that Ireland will transition, and again, it's been flagged there that we're moving really from the NZEB sort of era to the zero energy building era, or ZEB, and with that, we're expecting announcements to come in sooner rather than later, possibly before Christmas.
Another question from Niall here. For the Glasnevin house, how did you insulate the walls? Was there a WUFI analysis completed?
Yeah, so in this one to the front, not at all, there's no WUFI analysis done on the front of it. The front of it and the existing house is the area where it has a consideration when it comes to the traditional build-up. So it's a mix in this house. To the rear, to the new extension, it's externally insulated, and then to the front, again, appropriate insulations have been used in that regard.
And from Enda, we have, what are the typical problems or issues you might have encountered in any EnerPHit retrofit project?
Did I say that again, Lisa? I just missed that.
What are the typical problems or issues you might have encountered in any EnerPHit retrofit project?
Yeah, so typically, and the same is true to new build passive house. What you're always trying to get to is a situation whereby the project's framed to where its destination is going to be at the very start, at day dot. It's very hard to shoehorn projects into methodologies like passive house, be it EnerPHit or be it passive house plus, passive house premium, if they're not very well conceived at the very start. So that's probably one of the first challenges that oftentimes is the biggest single barrier. Then more in the nuts and bolts of it, it's typically the airtightness that you really want to challenge and have a strategy for that's very relevant. Or that's going to yield a big result. So again, even talking about Glasnevin and the EnerPHit that we've profiled for you, it's right on the number one at this moment in time. There's very little wiggle room within it. So there's a degree of challenge all the time in that area with airtightness. The other one that would typically present itself is thermal bridging. Although I have to say, more and more, there's easier and easier solutions with respect to that, and more knowledge as well about where the impacts would be there. And the same actually to maybe go back a step on the air tightness. The air tightness paints, for example, in recent years have been excellent in terms of, so I suppose, providing solutions that really work. Yeah.
Thanks, Barry. And just following on from that, Andrew had a similar question about challenges. He also asked, are older structures or any other aspects such as air tightness that you'd mentioned, are you finding a general increase in homeowners looking for EnerPHit standard? And do you see it becoming a mandatory standard in the future?
Yeah, that's a really good question as well. I do see, I suppose, a rise all the time in, say, knowledge with the general public around this, and also with people maybe having ambitions towards EnerPHit. More and more, that's something that they want to attain to, and we're seeing the industry respond to that as well. Again, it's extraordinary the amount of people that are now much more in this building physics space, if you like. And then the second part of that question about, do I see the likes of EnerPHit becoming mandatory? My feeling is that this will all seep into the general consciousness more than anything else. I don't see passive house, let's say, being this standard in Ireland. But what I would see is a migration of, let's say, the genesis of it, the physics of it, the 5 principles really being incognito within our building regulations. And the direction of travel would indicate that I'm right on that. We are seeing all the while, just that slow incremental, I suppose, transition to something that's very, very close or similar to what certified passive house is. And again, in that, I think the key word is quality and performance. If I can say 2 words, really, that's probably, and that's what we all want. We want a built environment that performs. So unfortunately, for far too long, it's still not occurring. Like we do have a situation, and again, it's widely acknowledged that the BER methodology does have in it a very particular performance gap. And with it, and again, I think the BER thing is an excellent tool for the sector, for the industry, for people. It really helps communicate, and it will improve again over time. And again, that's part of the EU directive coming as well, is that there might be changes in that space. But what you would often see is, or what's worth pointing out, is that the building energy rating methodology only counts 8 hours of every day. It also leaves out 4 months of the summer whereby no energy is used. And it also has every single house in Ireland located at Dublin Airport. So how wouldn't there be a performance gap notionally with that methodology? Whereas Passive House allows for much more granularity in terms of the software PHPP and Design PH in terms of the modeling. So again, that's me phrasing that out. Hopefully that makes sense. Any questions on that, please reach out.
Thanks, Barry. One from Tom here, talking again about the EnerPHit standard and mandatory. What ways can we optimize our neighbourhood project engagement once these important EnerPHits become embedded, as you said, into the communities? Can there be local resource hubs or sharing places to build from? This is in terms of upscaling EnerPHits. So probably volume. Have we seen that?
Yeah, so that's interesting, and close enough to our hearts here at KORE. First thing I would say, we're on an EU project at the moment, which is a follow-on project with lots of the similar partners to our Circular Reno project. Our Circular Reno project was exploring supply chains and Irish manufacturing of Irish bio-based installation materials. But our new project, which is a follow-on, is called ERIC, EAERO, or RC, sorry, ERIC. And with that is right aligned to that question, whereby we're exploring in that project with European partners how we can construct different ways of doing group retrofit, like collective buying, crowdfunding, and again knowledge sharing in that regard, but again in the community at a district level. So that's a very interesting project, and we're delighted to be involved in it. But even to show and to illustrate, the good work that's going on with the SCI, they have established the sustainable energy communities all around the country. There's I can't remember how many hundred of those, and each of those, I suppose, like anything, are at different levels of activity. But the more mature they get, the more empowered they're becoming, and the more knowledge they're accruing. And that I'd be very confident as a strategy will yield probably a lot of what was framed in that question into the future. So I would say that's all quite positive. And again, if you marry that with what I said in answering one of the previous questions, things like EnerPHit and the physics and the quality and the performance that's within, say, the passive house methodology, and what's happening at a societal level, there will be a convergence of those in due course. Yeah.
Another question here. Can you give an idea of how much the Glasnevin upgrade was?
Financially?
Yeah.
Yeah, I actually don't know the figure off the top of my head, but you are talking, I suppose, a significant investment there. I will quote my own house, which I think is probably quite similar. You are talking about probably the $250,000 mark in terms of 250,000 or whatever, in terms of that level of expenditure to and that reflects the depth of works that was being done to that home, again stripped right back and to the rear, effectively a whole entire new build up across 3 floors of construction. When you looked at my own, which is actually the photograph in on screen, we had a bungalow that we only kept 3 walls really in the end. The plan was to keep all 4 walls, but one became structurally unsound. And we rebuilt back from there. And again, very similar to the Glasnevin project, you're in that space of $250,000 or slightly more. But to do what the industry does and rightly does is compare prices per meter squared. I was able to do that for less than €2,000 a meter squared. I'd say the Glasnevin thing would have a higher price per meter squared. It's something in the region I'd imagine in and around €3,000 a meter squared. And with that's still significantly cheaper than new build construction and again new build construction if you were buying typically as well when you do that subdivision down. So and again, just when we're on it, I did look at projects in-house here internally during the week, and I seen 2 projects in Donegal that were coming in with a price for the home to go from a C, I think it was a low C, to an A, and they were coming in with figures at €250 a meter squared, and another one at €500 per meter squared. So retrofit is definitely, and again, I'll go another step further around the cost issue here and where that question is probably coming from. We're finding that retrofit is growing, not because there's the one-stop shops, of course that would be part of it, and it's much more, I suppose, being talked about in the media and various bits and pieces. But what we would be seeing is a lot of, let's say, first-time buyers, typical house in the country, for example, to take it away from Dublin for a minute, would have things where the go-to move was always to build potentially in a green field down the road or on the family farm or this type of arrangement. But what is happening now is that maybe is moving into an area where it's cost prohibitive with building costs. But to look at a vacant derelict project for the first time, builder, the young professional, they're pursuing projects like that and then putting their own flavour on it with architecture and all the rest of it, and availing of the grant offering that's there. And when all's said and done, it's probably a much cheaper avenue maybe in the end to get onto the property ladder and to get into a quality, high performing home. Yeah.
Thanks very much, Barry. Has anybody got any more questions? If not, you can see here on the screen our website, www.koreretrofit.com, where you can find more information. You can also email us at info@koreretrofit.com if you'd like a free consultation, or if you have any questions from the webinar or any of our schemes, the one-stop shop, the traditional or the vacant derelict. You can give us a call, and we're on all major social media outlets. And keep tuned to see the final project with the Glass Nevin House. So thank you everybody for joining us, and thank you, Barry, for giving us a wonderful presentation.
Thanks, Lisa. Yeah, thanks everyone.
Take care. Bye.